Hello scientists, welcome to today's chemistry class, and in today's chemistry class we'll be discussing relative atomic mass RAM and relative molecular mass RAM. Relative atomic mass RAM of an element is the average mass of one atom on a scale in which one atom of carbon-12 weighs and it has no unit. For example, the relative atomic mass of sodium is equals 23. That of chlorine is equals 35.5. Remember in our previous class when we did isotopes to get this. So we have another one, we have hydrogen, which is equals to 1. Then relative molecular mass, on the other hand, is the sum of the relative atomic mass of elements that makes up the molecules of the substance or compound. So that is the difference between relative atomic mass and relative molecular. So relative atomic mass is just for one atom of an element, like for an element, while relative molecular mass is the combination of the atoms of elements that makes up the compound or substance. On the board we have an example. The example reads, calculate the relative molecular mass of 1. Sodium chloride, 2. Calcium hydrogen trioxocarbonate, 4. Then to do that, the first thing we do, we have solution. So the first one we have 1, that is sodium chloride. And sodium chloride is given as, sodium is 23, that is the relative atomic mass of sodium, 23, plus relative atomic mass of chlorine is 35.5. So when you add them up, you have 58.5, no units. Recall I told you that relative molecular mass, relative atomic mass, they don't have units. You can equally be told to calculate the percentage composition. Percentage composition of sodium in sodium chloride. So to get that, you have, what is the sodium content? You have 23 over the total, which is 58.5 times 100 over 1. So 23 over 58.5 times 100 over 1 is equals 39.32%. So you can equally be told to calculate the percentage composition of each element that makes up the compound. So to the second example, we have calcium hydrogen trioxocarbonate, 4. Calcium is 40, then plus these two affect everything inside this bracket. We have 2 outside, then we have a square bracket. Hydrogen is 1, plus carbon has relative atomic mass of 12, while oxygen is 16. So we have 3 times 16. Then you have your brackets closed, then your square brackets closed. Then this is equals, we have 40 plus 2 into, we have 1 plus 12 plus 3 times 16 is 48. So square brackets closes, we have 40 plus 2. Then when you add this up, you have 61. So this is equals 40 plus 1, 2, 2. So at the end, you have that the relative molecular mass of this compound is 162. So that is the relative molecular mass of calcium hydrogen trioxocarbonate, 4. So percentage composition of oxygen in the compound. So we had oxygen, that is 3 times 16. So we have 48 times 2. So we have 2 times 48 over the total, which is 162 times 100 over 1. So we have this to be 98 over 162 times 100 over 1. So to get the percentage composition of oxygen in the compound, so I want you to write the value of the answer, so which is 98 over 162 times 100 over 1 in percentage. So that is the percentage composition of oxygen in calcium hydrogen trioxocarbonate 4. On the board, we have an exercise. Calculate the relative molecular mass and percentage composition of each element in magnesium hydroxide. Magnesium has relative atomic mass of 24, then hydrogen is 1, while oxygen is 16. So calculate the relative molecular mass and the percentage composition of each element that makes up the compound. So write your answer in the comment section. I will be there reading your answers and marking them. Thank you very much.